Picture this. It's 300,000 years ago, maybe earlier, maybe later. Nobody knows exactly. A small group of early humans sits around a fire somewhere in Africa. The flames dance against the darkness. Predators call in the distance. Children huddle close to their mothers, and then one person makes a sound. Not a grunt, not a scream, not an alarm call like every other animal makes. Something different, something intentional, a sound that carries meaning, specific meaning, chosen meaning, the first word, and everything changes forever. Of course, that's not how it actually happened. It couldn't have been that simple, that sudden, that dramatic. But somewhere, somehow, at some point in our deep past, it did happen. The most important transformation in human history. The moment when meaningless sounds became language, when noises became words, when our ancestors crossed an invisible threshold that separated them from every other creature on Earth. This is the greatest story never told, literally. Because words don't fossilize. You can dig up ancient bones and stone tools, you can analyze DNA and carbon date fire pits, but you can't excavate a conversation from 200,000 years ago. You can't find the fossilized remains of the first joke, the first lie, the first time someone said, "I love you." All of that is gone, vanished into the air the moment it was spoken. What we're left with is a mystery. How did our ancestors go from the simple alarm calls and emotional outbursts that every primate makes to the complexity of human language? How did grunts and gestures transform into Shakespeare and philosophy, into songs and stories, into the ability to describe things that don't exist, to talk about the past and future, to share ideas that spark revolutions? Think about what language actually is. It's not just communication. Bees communicate. They do elaborate dances that tell other bees exactly where to find flowers. Whales sing songs that travel hundreds of miles through the ocean. Chimpanzees have dozens of distinct calls for different situations. But none of that is language. Not really. Language is something else entirely. It's infinite. You can combine words in ways that have never been spoken before, and others will understand you. You're doing it right now, understanding sentences that have never existed until this moment. Language lets us share not just information, but imagination. We can describe things we've never seen, plan for events that haven't happened yet, tell stories about people who never existed. We can lie, speculate, hypothesize, dream out loud. No other animal can do this. And somewhere in our evolutionary past, neither could we. So what happened? When did it happen? How did it happen? These are the questions that have haunted scientists, linguists, and anthropologists for centuries. And here's the uncomfortable truth. We don't really know. We have theories, fascinating theories, compelling evidence, tantalizing clues, but no definitive answers. This is history's missing chapter. The story that should be written in stone but exists only in shadows and speculation. What we're about to explore together isn't a simple tale with clear answers. It's a journey into uncertainty, into the blurry space between what we know and what we can only guess at. We'll look at the evidence, the competing theories, the surprising discoveries that hint at when and how our ancestors learned to speak. We'll meet the scientists who are trying to solve this mystery, using everything from fossil skulls to computer simulations of ancient vocal tracts. But we'll also acknowledge what we don't know, what we might never know. Because the origin of language isn't just a scientific puzzle, it's a profound mystery about what makes us human. And maybe, just maybe, some mysteries are meant to be explored rather than solved. So let's begin at the beginning, or at least as close to the beginning as we can get. Before we can understand how humans learn to speak, we need to imagine a world without words. Not just quiet, not just simple, but fundamentally different from anything we can easily conceive. Because for millions of years your ancestors lived, loved, fought, and cooperated without a single word passing between them. Picture this. You're living 2 million years ago. Maybe you're Homo erectus, one of our most successful early ancestors. You've mastered fire. You make sophisticated stone tools. You live in social groups of maybe 20 or 30 individuals. You have a rich emotional life, complex social relationships, detailed knowledge of your environment. But you can't talk about any of it. Not really. So how do you communicate? The same way our closest living relatives do today. Watch chimpanzees for an afternoon, and you're seeing a window into our wordless past. They gesture constantly. A raised arm means warning. Extended hand means begging for food. Specific facial expressions convey aggression, fear, playfulness, submission. They make vocalizations, dozens of distinct sounds, pant hoots that carry for miles through the forest, warning others about food sources or threats, screams that signal danger, soft grunts that maintain contact between mothers and infants. But here's what's crucial. These aren't words. They're involuntary emotional expressions. A chimp can't choose to fake a fear scream when it's not actually afraid. It can't describe a leopard it saw yesterday or warn about a threat that might come tomorrow. Every vocalization is tied to the immediate present, to current emotional states. There's no past tense, no future planning expressed through sound, no abstract concepts. Your early ancestors communicated the same way. When you found food, you made excited sounds that drew your group to you. When you spotted a predator, involuntary alarm calls erupted from your throat before you even thought about it. When you wanted to reconcile after a conflict, you used gestures and facial expressions that your companions understood instinctively. And it worked. For millions of years, this system was enough. You could coordinate hunts through gestures and grunts. You could maintain social bonds through grooming and body language. You could teach your children basic skills through demonstration and imitation. You didn't need words to know who was your friend and who was your rival. You could read that in posture, in eye contact, in the subtle micro-expressions that flickered across faces. But you couldn't tell stories. You couldn't explain why you preferred one hunting route over another. You couldn't warn children about dangers they hadn't yet encountered. You couldn't share your dreams or describe your fears. Your inner life was as rich as ours, the evidence suggests, but it was trapped inside your skull, accessible to others only through crude emotional displays and physical actions. Before we go further into this mystery, I'm curious. Where in the world are you listening from right now? What time is it where you are? Drop a comment. There's something beautiful about knowing this story is being heard across different places and times, connecting us through this exploration of how connection itself began. Somewhere between your wordless ancestors and modern humans with our endless vocabulary, something emerged that anthropologists call proto-language. Not quite animal calls, not quite true speech, maybe intentional vocalizations with rough meanings, maybe strings of gestures combined in primitive sequences. Some researchers think it sounded like the two-word utterances of human toddlers. Want food, go water, danger close. Simple combinations that could convey slightly more complex ideas than single calls, but nothing like the recursive, infinite flexibility of modern language. This was the silent world from which we came, and somehow, across hundreds of thousands of years, that silence became speech. Here's something to think about. You couldn't speak if you tried. Not because you don't know how, but because your body, as it is right now, would have to be fundamentally different. Your throat would need to be rearranged. Your brain would need entire regions dedicated to processing sound patterns. You'd need bones that exist for no other purpose than making words possible. Speech isn't just a skill we learned. It's written into our anatomy in ways that make us unlike almost any other creature on Earth. Start with your throat. Right now, your larynx, your voice box, sits low in your neck, much lower than it does in chimpanzees, gorillas, or any of our closest primate relatives. In most mammals, the larynx sits high, practically at the back of the mouth. This arrangement is actually safer. It lets animals breathe and swallow at the same time, prevents choking, keeps the airway protected. But humans gave up that safety for something else entirely. Our larynx descended. Over millions of years of evolution, it gradually dropped lower in the throat, creating a long pharyngeal cavity above it. This seems like a terrible trade-off at first. We can't drink and breathe simultaneously like other animals can. We choke easily. Every year, thousands of people die from aspirating food or liquid into their lungs, a problem that's almost non-existent in other primates. Evolution doesn't usually make changes that increase mortality risk unless those changes provide massive advantages elsewhere, and the advantage is sound. That long pharyngeal cavity above our descended larynx acts like a resonating chamber, like the body of a guitar or the tube of a trumpet. It lets us modify sounds in ways no other primate can. We can shape vowels, create consonants, produce the incredible range of phonemes that make human language possible. A chimpanzee can make maybe a dozen distinct vocalizations. Humans can produce around 200 different speech sounds, and we combine them in essentially infinite ways. The descended larynx starts developing in human infants around 3 months old. Before that, babies actually can breathe and swallow simultaneously, just like other mammals. Then something changes. The larynx begins its descent, and suddenly the infant is vulnerable to choking in ways it wasn't before. But it's also ready to start experimenting with the sounds that will eventually become words. Now look deeper, at the bones themselves. In your neck, floating free without connecting to any other bone in your body, is the hyoid. It's a small horseshoe-shaped bone that anchors the muscles of your tongue and larynx. Most animals have a hyoid, but in humans it's shaped differently, positioned differently, connected to muscles in ways that exist nowhere else in the animal kingdom. The human hyoid is essentially a bone dedicated to speech. Finding ancient hyoids is rare. Bones this delicate don't fossilize easily. But when archaeologists discovered a Neanderthal hyoid in a cave in Israel, the scientific world took notice. It was virtually identical to a modern human hyoid. Same shape, same size, same muscle attachment points. This suggested that Neanderthals had the same basic vocal anatomy we do, that they could potentially produce the same range of sounds. But having the hardware doesn't necessarily mean you have the software. That's where genetics enters the picture. In 2001, researchers discovered a gene called FOXP2. It's not unique to humans, lots of animals have versions of it, but the human variant is different. 2 small mutations separate our FOXP2 from the chimpanzee version, and those 2 tiny changes have enormous effects. Humans with damaged FOXP2 genes have severe language impairments. They can think, they can understand concepts, but they struggle with the precise motor control needed for speech and with the grammatical structures that make language work. When did these FOXP2 mutations appear? The genetic evidence suggests they became fixed in human populations sometime after we split from our common ancestor with chimpanzees, but the exact timing remains frustratingly unclear. Some estimates put it at 200,000 years ago. Others suggest it could be much older, perhaps over 500,000 years, which would mean Neanderthals and Denisovans inherited the same mutations. And here's where it gets really interesting. When scientists sequenced Neanderthal DNA from fossils, they found that Neanderthals had the same FOXP2 mutations we do. The exact same changes that are crucial for human speech. This wasn't convergent evolution, where similar traits develop independently. This was shared inheritance. Neanderthals got these mutations from the same ancestral population we did, probably from those bottleneck survivors who possessed the genetic foundation for speech, before the three human lineages diverged. But anatomy and genetics are only part of the story. The real magic happens in the brain. Three regions in particular make human language possible. Broca's area, located in the frontal lobe, handles speech production and grammar. Wernicke's area, in the temporal lobe, processes language comprehension, and connecting them is a bundle of nerve fibers called the arcuate fasciculus, a neural highway that lets these two regions communicate at incredible speeds. These structures exist in other primates, but they're smaller, less developed, less interconnected. In humans, they're massively enlarged and elaborately connected to other brain regions. Broca's area in particular shows connections to areas controlling facial muscles, tongue movement, breath control, everything needed for the precise motor coordination that speech requires. This isn't simple communication. This is orchestration of dozens of muscles firing in precise sequences to produce sounds that other humans can decode into meaning. The fossil record gives us tantalizing hints about when these brain structures developed. Cranial casts, impressions left on the inside of ancient skulls, show that the pattern of convolutions in the brain started changing sometime around 2 million years ago. The areas that would become Broca's and Wernicke's regions began to expand. By the time we get to Homo heidelbergensis, the common ancestor of modern humans and Neanderthals, the brain structure looks remarkably modern. The hardware was in place. But here's the chicken and egg problem that keeps anthropologists awake at night. Did our anatomy change to enable speech, or did the survival advantage of better communication drive our anatomy to change? It's probably both. Natural selection doesn't work in straight lines. It creates feedback loops. Maybe early humans with slightly descended larynxes could make more distinct warning calls, giving their group survival advantages. Over generations, groups with better communication survived more often, had more offspring, passed on the genes for descended larynxes and enlarged language areas. Those enhanced abilities created pressure for even better communication, driving further anatomical changes. It's a cascade effect. Each small improvement in anatomy makes more complex communication possible. More complex communication provides greater survival advantages. Greater survival advantages intensify selection pressure for even better anatomy. Round and round for millions of years, until you end up with a species that has fundamentally restructured its throat, developed specialized bones, mutated crucial genes, and rewired significant portions of its brain, all in service of something that didn't exist when the process started. We are talking proof that evolution can build something magnificent from accumulated accidents and survival pressures. Our bodies are monuments to the power of words, shaped by them before the first word was ever spoken. So here's where things get really speculative and honestly kind of fun, because nobody knows how language actually began. We have theories, lots of them, ranging from plausible to absurd, from carefully researched to basically just educated guesses, and the truth is, we might never know for certain. But each theory, even the ones that sound ridiculous at first, tells us something interesting about how humans think, how we communicate, how we became the talking apes that conquered the planet. Let's start with one of the oldest ideas, the bow-wow theory. The name sounds silly because it kind of is, but the basic concept makes intuitive sense. This theory suggests that language began when early humans started imitating the sounds around them. Animals, thunder, wind, water. You hear a bird call and you mimic it. You hear water rushing and you make a whooshing sound. Eventually these imitative sounds become words. Dog sounds become the word for dog. Thunder sounds become the word for thunder. It's simple, elegant, and probably at least partially wrong. The problem is that most words in modern languages don't sound anything like the things they represent. The word tree doesn't sound like a tree. The word stone doesn't sound like a stone. Sure, we have some onomatopoeia, words like splash or buzz or meow that do mimic sounds, but they're a tiny fraction of any language. If language started purely through sound imitation, you'd expect way more words to sound like their reference. But here's the thing, the bow-wow theory might not be completely wrong either. Some recent research suggests that all languages have subtle sound symbolism, unconscious associations between certain sounds and certain meanings. Words for small things tend to use high-pitched vowels. Words for large things use deeper sounds. Maybe the bow-wow theory captures something real about how our brains first started connecting sounds to meanings, even if it doesn't explain everything. Then there's the yo-he-ho theory, and yes, these names really were coined by scholars who apparently had a sense of humour. This one proposes that language emerged from rhythmic chants during communal labour. Picture your ancestors hauling a heavy log, lifting a large stone, pulling in a fishing net. Everyone needs to coordinate their effort, pull at the same time, lift together. So someone starts making rhythmic sounds. In time with the work, others join in. The rhythm helps coordination. Over thousands of generations, these simple work chants become more complex, more varied, eventually evolving into full language. The appeal of this theory is that it connects language to something we know early humans were doing, cooperative labour. And rhythm is fundamental to all human languages. Every language has prosody, stress patterns, ways of organising sounds in time. Maybe these rhythmic foundations really did come first, with meaning getting layered on top later. The problem is that chanting during work doesn't require the kind of complexity that language has. You don't need grammar to coordinate pulling a net. You don't need a vocabulary of thousands of words to time a group lift. So while the yo-he-ho theory might explain how humans first started using their voices in coordinated ways, it doesn't really explain how we got from there to full language. More intriguing is the gestural theory, and this one has gained serious scientific credibility in recent decades. The idea is that language didn't start with sounds at all. It started with hand gestures. Your ancestors pointed at things, mimed actions, used their hands to communicate long before they used their voices. This makes evolutionary sense. Primates are already excellent at gestural communication. Chimps and bonobos use dozens of distinct hand signals to convey meaning. Our common ancestors probably did too. So maybe human language began as an elaboration of this existing system. More gestures, more complex combinations, eventually a full gestural language as sophisticated as any modern sign language. Then, according to this theory, something shifted. The mouth started taking over functions that had belonged to the hands. Why? Because hands were busy. When you're carrying tools, babies, food, you can't spare your hands for communication, but your mouth is free. So natural selection favoured individuals who could transfer their gestural vocabulary to vocal sounds, using their tongue and lips to create the variety of sounds that hands had been creating through movement. This theory is supported by some fascinating neuroscience. The brain regions that control hand movements and speech production are right next to each other and heavily interconnected. When you speak, your hands tend to gesture automatically. When you gesture, speech areas of your brain activate. Maybe this overlap isn't coincidence. Maybe it's evolutionary history, the trace of an ancient time when hands did what mouths do now. Then there's the social grooming hypothesis, proposed by anthropologist Robin Dunbar. He noticed something interesting about primates. They spend huge amounts of time grooming each other, picking through fur, removing parasites. But grooming isn't really about hygiene. It's about social bonding. It's how primates maintain relationships, build alliances, keep groups cohesive. The problem is that grooming is time-consuming, and you can only groom one individual at a time. As human groups got larger, Coming out of the bottleneck and expanding across new territories, physical grooming became impractical. You'd need to spend all day grooming just to maintain bonds with everyone in your band. So, according to Dunbar, humans developed vocal grooming to replace physical grooming. Language, in this view, isn't primarily about sharing information. It's about maintaining social bonds efficiently. You can vocally groom multiple people at once just by talking in a group. You can strengthen relationships through conversation much faster than through picking bugs out of someone's hair. This explains why so much human conversation is basically meaningless small talk. We're not exchanging vital information when we chat about the weather. We're vocal grooming, maintaining social bonds through sound. Perhaps most touching is what some researchers call the putting the baby down theory. For millions of years, primate mothers carried their infants constantly. Babies clung to their mother's fur, staying in physical contact almost all the time. But as humans lost body hair, babies couldn't cling anymore. Mothers had to carry them manually, which meant they sometimes needed to put them down to do other work. A baby left on the ground is a terrified baby. It needs reassurance that mother is still nearby, still protecting. So mother started making soothing sounds, soft vocalizations that said, "I'm here, you're safe, I haven't abandoned you." Over time, these comfort sounds became more elaborate, more varied, eventually forming the foundation of language. It's a beautiful idea. That language began not as a tool for hunting or fighting, but as an expression of love, as a way to comfort a frightened child. The truth is, all of these theories might be partially correct. Language didn't necessarily have one single origin. Maybe it emerged from multiple sources simultaneously. Sound imitation, and rhythmic work chants and gestures and social bonding and infant comfort, all blending together over tens of thousands of years into something unprecedented. There's a reason the Linguistic Society of Paris banned all speculation on language origins in 1866. Scholars had been arguing for decades, proposing wild theories with no evidence, getting nowhere. The society basically said, "Enough, we're wasting our time, let's focus on what we can actually study." That ban, in a way, is still in effect. Most linguists treat language origins with extreme caution, acknowledging how little we really know, but not knowing for certain doesn't make the question less fascinating. It makes it more so. So scientists have to piece together the timeline from indirect evidence, from anatomy and archaeology and genetics, and they've come up with wildly different answers. Some think language emerged nearly 2 million years ago. Others insist it couldn't be more than 100,000 years old. That's not a small disagreement. That's the difference between language being an ancient inheritance that shaped our entire evolutionary journey and language being a recent invention, barely older than agriculture. Let's start with the early timeline theory. The idea here is that language emerged with Homo erectus, our ancestor who first spread out of Africa around 2 million years ago. Erectus was impressive. They had significantly larger brains than earlier hominins. They controlled fire systematically. They made sophisticated stone tools, and most importantly, they colonized half the planet. They spread from Africa into Europe and Asia, surviving in environments ranging from tropical forests to temperate grasslands. Some proponents of the early theory argue that this kind of global expansion would have been impossible without language. How do you coordinate a group migration across unfamiliar territory without words? How do you teach the next generation where to find water sources they've never seen? Which plants are edible in regions you've just discovered? How to hunt animals your people have never encountered? Trial and error would kill you long before you learned enough to survive. Tool-making adds weight to this argument. Erectus didn't just make simple choppers. They crafted hand axes that required dozens of precisely placed strikes to shape, following mental templates that took years to master. Teaching someone to make an Acheulean hand axe through pure demonstration would be incredibly difficult. Show them with language, explain the principles, Describe what you're thinking as you work, and suddenly the knowledge transfers efficiently. Some researchers have done experiments where modern people try to learn stone tool-making either with or without verbal instruction. The language group learns faster, makes fewer mistakes, produces better tools. If that's true for us, wouldn't it have been true for Erectus? But here's where it gets complicated. Other scientists look at the same evidence and see something completely different. They argue that Erectus tools, impressive as they are, barely changed for over 1 million years. The hand axes found in Africa from 1.7 million years ago look almost identical to ones made in Europe 500,000 years ago. If Erectus had true language, why didn't technology explode? Why didn't innovation accelerate? Modern humans with language can go from the first airplane to landing on the moon in 66 years. Erectus made the same tools for 1 million years. That doesn't sound like a species with fully developed linguistic abilities. The late timeline theory pushes language emergence to somewhere between 50,000 and 100,000 years ago, coinciding with what archaeologists call the Great Leap Forward. Around this time, the archaeological record transforms. Suddenly you see cave paintings, carved figurines, sophisticated jewelry, elaborate burial practices, evidence of long-distance trade networks. The toolkit explodes in diversity and complexity. Musical instruments appear. There's unmistakable evidence of symbolic thinking, abstract reasoning, the kind of mental activity that seems impossible without language. Proponents of this theory argue that all the truly human behaviors, everything that separates us from other primates, only appear in the last 100,000 years. Before that, our ancestors were smart, sure, but they weren't modern, they weren't us. Language was the final piece, the innovation that transformed clever apes into beings capable of art and religion and science. The timing even aligns with genetic evidence. Remember that population bottleneck from 930,000 to 813,000 years ago. Some researchers think the neural reorganization that occurred during and after that crisis created the cognitive architecture necessary for language. The brain changes that allowed symbolic thinking, that made it possible to use arbitrary sounds to represent complex ideas. If that's right, language couldn't have emerged until after the bottleneck survivors had evolved into something new. But most linguists and anthropologists today favor a middle path, the gradual emergence hypothesis. This theory suggests language didn't appear suddenly like a light switch. Instead, it evolved slowly over hundreds of thousands of years, maybe even longer. Early forms might have been extremely simple. A handful of words, basic grammar, just enough to coordinate hunting or teach tool-making more efficiently. Over time, as human brains grew larger and more sophisticated, language grew with them. More words, more complex grammar, more abstract concepts. Generation by generation, millennium by millennium, human communication became more nuanced, more flexible, more powerful. This gradual model makes evolutionary sense. Natural selection doesn't usually produce dramatic leaps. It refines and improves existing systems incrementally. Maybe Erectus had proto-language, something more sophisticated than chimp communication, but far simpler than what we have today. Maybe the species that came after them, Homo heidelbergensis, our common ancestor with Neanderthals, expanded that system further. Maybe full modern language only emerged in the last few 100,000 years, but it was built on foundations laid millions of years earlier. The spread of humans out of Africa might offer clues. When our ancestors finally left around 60,000 years ago, they moved fast. Within 20,000 years, they'd colonized Asia, Europe, Australia, and eventually the Americas. They adapted to Arctic tundra, tropical rainforests, high-altitude plateaus, small islands. They developed hundreds of distinct cultures, each with specialized knowledge about their environment. That kind of rapid, successful colonization of diverse environments suggests sophisticated communication. Not just a few words, but the ability to share complex information, to teach intricate skills, to maintain social cohesion across vast distances. That sounds like people with language very much like ours. But here's the honest truth. We don't know. We probably can't know, not with certainty. Language emerged sometime between 2 million and 50,000 years ago, which is an embarrassingly huge range for something so fundamental. It might have appeared suddenly or evolved gradually. It might have been the cause of human uniqueness, or the consequence of other changes that made us special. The timeline mystery remains unsolved, perhaps unsolvable. What we do know is that whenever language emerged, it changed everything that came after. Here's something that should keep you up at night. Imagine you're a modern human, around 50,000 years ago, somewhere in what's now France or Spain. You've travelled north from Africa with your band, following herds of mammoth and bison into territories your people have never seen before. And then one day, near a river valley, you encounter them. Other humans, but not quite like you. They're shorter, more muscular, with massive brow ridges and faces that look both familiar and utterly alien. They're Neanderthals. And here's the question that haunts every archaeologist who studies this period. When you met them, could you talk to each other? For most of human history, we assume Neanderthals were brutish, inarticulate cave dwellers, grunting primitives who barely qualified as human. Then we started looking at the evidence, and everything changed. The first clue came from a tiny bone in the throat. The hyoid bone sits at the base of your tongue and anchors the muscles you use for speech. It's delicate, rarely preserved in fossils. But in 1983, archaeologists excavated a Neanderthal skeleton from Kibara Cave in Israel, and there it was, a hyoid bone virtually identical to yours, same shape, same size, same muscle attachment points. This bone only makes sense if you're doing something incredibly complex with your vocal tract, something like speaking. But maybe that was a fluke. One bone doesn't prove anything. Then came the genetic evidence. In 2007, researchers successfully extracted DNA from Neanderthal fossils and sequenced a gene called FOXP2. This gene is crucial for speech and language development. Mutations in FOXP2 cause severe speech and language disorders in modern humans. Children with damaged versions of this gene struggle to coordinate the fine motor movements needed for speech. They have difficulty processing grammar and understanding complex sentences. FOXP2 is one of the most important genes for human language, and Neanderthals had the exact same version we do. The same mutations, the same amino acid sequences. Our version of FOXP2 emerged sometime after humans split from chimpanzees, probably during or shortly after the bottleneck. It's one of the genetic innovations that makes us human, and Neanderthals shared it. Not because we gave it to them through interbreeding. The genetic evidence is clear on this. They inherited it from the same common ancestor, developed it along the same evolutionary path, refined it through the same selection pressures. If FOXP2 gives us the capacity for language, it gave them the same capacity. Then researchers started looking at Neanderthal ear structure. Using CT scans of fossil skulls, they reconstructed the anatomy of the Neanderthal ear canal, the tiny bones that transmit sound, the structure of the cochlea where sound becomes neural signals. What they found was remarkable. Neanderthal ears were tuned to the same frequencies as modern human ears. Specifically, they were optimized for hearing sounds in the 2 to 4 kilohertz range. That's the frequency range of human speech. Most of the important consonants in human language, the sounds that carry the most information, fall within that range. Neanderthal ears were built to hear precisely those sounds. This isn't coincidental. Evolution doesn't waste resources building specialized equipment for no reason. If Neanderthals had ears optimized for hearing speech frequencies, they almost certainly were producing speech sounds. But here's where it gets even more fascinating. We know Neanderthals had culture. Complex, sophisticated, undeniably symbolic culture. They buried their dead with what appears to be ritual care. Neanderthal graves from multiple sites show bodies placed in specific positions, sometimes with objects placed nearby. At Shanidar Cave in Iraq, analysis of soil samples from a Neanderthal burial revealed pollen from multiple flowering plants. For decades, archaeologists debated whether this meant Neanderthals placed flowers in graves. Recent analysis suggests some of the pollen probably came from natural processes, but not all of it. The concentrations are too high, too localized. Someone probably did place plants there deliberately, meaningfully. They created art. For years, any cave paintings or decorated objects in Europe were automatically attributed to modern humans. Then researchers developed better dating techniques. And suddenly, some of the art got older. Much older. Old enough that only Neanderthals could have made it. Red ochre hand stencils in Spanish caves, dating to 65,000 years ago. Shell jewellery from Spain, 115,000 years old. Eagle talons with cut marks suggesting they were worn as pendants. Neanderthals were creating symbolic objects, decorating their bodies, leaving their marks on cave walls. This is the behaviour of minds capable of abstract thought, minds that could conceive of meaning beyond immediate survival. And here's the thing about symbolic thinking. It's almost impossible without language. Try to imagine creating art without internal dialogue. Try to imagine developing burial customs without the ability to share ideas about death and meaning. Try to imagine maintaining complex social structures without communication more sophisticated than pointing and grunting. Their tool technology suggests the same thing. Late Neanderthal tools show regional variations, distinct styles that persisted across generations within specific populations but differed between groups. This is cultural transmission, knowledge being passed from master to apprentice, from parent to child, from one generation to the next. You can teach simple tool-making through demonstration alone. But teaching complex multi-step procedures with regional variations, that requires explanation, that requires language, but not everyone agrees. Some researchers argue that Neanderthal vocal tracts were subtly different from ours. Reconstructions based on skull shape suggest their larynx might have sat slightly higher in the throat, limiting their range of vowel sounds. Maybe they could produce some speech-like sounds, but not the full range of phonemes that modern human languages use. Maybe their language, if they had one, was simpler, more limited, capable of conveying concrete information but not abstract concepts. Others point out that we've never found Neanderthal art that's as complex as the elaborate cave paintings modern humans created. No animal murals covering entire walls, no sculptures, no evidence of counting or notation systems. Maybe their symbolic thinking wasn't quite as developed as ours. Maybe they were on the threshold of language but hadn't fully crossed it. But imagine just for a moment that they could speak. Imagine that 50,000 years ago, in a river valley in Ice Age Europe, two groups of humans met. Modern humans and Neanderthals, separated by 400,000 years of evolution, but still close enough to recognize each other as something almost familiar. Could they understand each other? Their languages would have diverged long ago, would have developed separately across different continents. But maybe there were still similarities, echoes of a common linguistic ancestor, basic words that hadn't changed too much. Maybe through gestures and repetition and patience they could communicate, share information about water sources and hunting grounds, warn each other about dangers. Maybe, around a shared fire on a cold European night, they told stories. We know they interbred. Modern humans carry Neanderthal DNA, evidence that our ancestors didn't just meet them, but lived with them, formed relationships with them, had children with them. And it's hard to imagine forming those kinds of bonds without communication, without conversation, without the ability to share not just information but experience, emotion, meaning. Did a Neanderthal mother sing to her half-human child? Did a human hunter learn Neanderthal words for the animals they pursued together? Did they compare their different myths about where fire came from, or why the stars moved across the sky? We'll probably never know for certain. The sounds they made vanished 40,000 years ago when the last Neanderthal died. No recordings, no written records, nothing but bones and stones and the faint genetic echoes in our own DNA. But standing in those ancient caves, looking at handprints left on walls by people who weren't quite us, it's hard not to wonder what they were trying to say, and whether, if we could hear them, we would understand. Probably not philosophy. Not at first. Their first words were almost certainly about survival. Imagine a campsite on the edge of a river, 300,000 years ago. The sun is dropping. The fire is going. Children are playing at the edge of the light. Somewhere out in the dark, something moves. Before language, you have two options. You can point. You can make a general alarm call, a panicked shout that means nothing more specific than danger. That's what most animals do. But with even a handful of shared words, everything changes. You don't just yell. You say leopard, there. You say quiet, children, close. You say tomorrow, no water upstream, dead zebra, rotting. Those simple phrases, if they existed, would have been worth more than any stone tool. They would have let you compress the whole complexity of your world into quick, low-energy packets of sound. You could warn, direct, coordinate, plan. You could shift other people's behavior not just in the next 5 seconds, but over the next day, the next season, maybe the next year. If you're looking for a candidate for the first content of human language, it was probably this. Information that changed what someone else did. Warnings were especially valuable. Snake under rock. Bee nest. Bad water. A single utterance could save a relative's life. Natural selection loves that. Groups that could transmit specific danger information faster than others would have outlived their neighbours. Food came next. Food is life, and it's also politics. Fruit there. Shellfish when water low, roots after rain. Buffalo passed 3 sleeps ago. These aren't just vague sounds. They're maps, coordinates, calendars, all hidden inside a few basic words. Once you can say where the food is and when it appears, you can start sending out foraging parties strategically. You can choose who goes, who stays. You can negotiate shares before the hunt even begins. You can keep track of who is generous and who is always just a little too close to the cooking pot. And that leads to something even more explosive. Talking about people. Because the moment your ancestors could reliably name individuals and refer to them when they weren't around, language stopped being just a tool for survival and became the engine of society. At first, the names themselves would have been a revolution. Giving something a stable sound, a word, locks it into your mind in a new way. A plant with no name is just a memory of a shape and a colour. A plant with a name, Cura, Bender, whatever the sound, becomes an entity. It can be listed, compared, tracked, taught. Don't eat red Cura. Green Cura good in dry season. Bender makes stomach hurt. Suddenly knowledge isn't just floating loosely in your head. It has anchors, labels. You can build chains of reasoning. The same was true for people. Once names solidified, social life deepened. You weren't just remembering faces, you were remembering reputations. Dari shares meat. Toma lies. Ask Leni about roots. Follow Heka for water. Names turn shifting impressions into stable concepts. They let you carry around a mental database of your group in words. That's not just convenient, It transforms how you think. You can compare, predict, and judge in ways that are impossible without labels. And with names comes something even more mysterious: the ability to talk about what is not here. Linguists call this displacement, the capacity to use language to refer to things that are absent in space and time. Most animals can't do this in any complex way. Their signals are tied tightly to the present. Your ancestors slowly broke that chain. Now you can say, the lines were here yesterday. You can say, in the dry time we will go to the far water. You can even say, last cold season my brother died there. Those are not just sentences. They are time travel. They let you pull the past into the present and the future into the campfire circle. Think about what that did to planning. Instead of reacting to weather and animals as they appeared, bands could share memories of past droughts, past migrations, past disasters. They could say, when the sky does this, the rains will fail. They could decide together to move before the catastrophe arrived. Over thousands of years, displacement would have tightened the grip of culture on survival. The more precisely you could talk about the past, the more accurately you could aim your future. But human beings didn't only use this new power for noble collective planning. They used it to gossip. Anthropologists who work with modern hunter-gatherers, from the Hadza of Tanzania to the Jew/Hwansi of the Kalahari to Aboriginal groups in Australia, notice something striking. A huge portion of daily talk is about other people. Who did what? Who slept with whom? Who broke a rule? Who carried the heavy load and who faked an injury to get out of work? Some researchers argue that gossip is not a side effect of language. It might be one of the reasons language became so complex in the first place. In tiny bands where everyone depends on everyone else, reputation is survival. You need to know who is brave in a crisis, who hoards food, who loses their temper, who steals, who shows kindness to orphans. You can't directly witness every act, but language lets you pull your observations. Keho kept meat for himself. Mara helped old Nami walk. Don't trust Bira with children. These sentences shape reality. Over time, they can raise or destroy leaders. They can encourage cooperation, punish cheaters, and keep powerful individuals from controlling the group. In many hunter-gatherer societies today, coordinated gossip is used to bring arrogant people back in line, to prevent dominance hierarchies from forming. It's very possible your ancestors were doing something similar, tens or hundreds of thousands of years ago, speaking softly beside the fire about who could be trusted when the next hard season came. We can't listen in on those ancient conversations. But modern hunter-gatherer languages give us clues. They're often incredibly rich when it comes to describing movement across landscapes, subtle changes in weather, animal behavior, and kinship ties. There are separate words for older brother versus younger brother, mother's brother versus father's brother, precise terms for relatives related by marriage, obligation, or adoption. This suggests that early speech wasn't just about pointing and shouting. It was already woven deeply into the fabric of social life and ecological knowledge. Words mapped territories, skies, relationships, and feelings. And within that web of talk, something else would have quietly emerged. Stories. You can imagine the first storyteller almost by accident. Someone who went farther than others on a hunt. Someone who survived something terrifying. Someone who came back, sat down, and instead of just saying lion there ran, began to chain events together. Yesterday, when the sun was high, I went beyond the red hill. I saw fresh tracks. I followed them. The wind changed. The lion smelled me. I climbed the rock. It waited. I threw a stone. It ran this way. Next time, we can trap it there. At first, the story is just extended information. A longer report, a more detailed warning. But once your mind gets used to linking events in a sequence, attaching them to named places and named people, the door opens to something more. Narrative. The moment you can tell a story, you can share not just facts, but experiences. You can transmit fear, courage, doubt, cleverness. You can let others rehearse dangers in their imagination before facing them in reality. A child who hears a story about a snake at the riverbank may step more carefully the next year, even if they never saw that snake themselves. Over time, the storyteller becomes a new kind of specialist. Not just a hunter or gatherer, but a weaver of shared memory. Stories stabilize group identity. They explain why your band lives here, why you trust these people and fear those people, why this ritual matters and that hill is sacred. Some of the very earliest myths may have begun as simple teaching tales. Once, a child ate the wrong root and died. That's why we never eat it. But even that is enough to show you the real power of the first words. They didn't just label the world, they stitched it together. They made invisible connections visible. They allowed memories to outlive individual bodies, allowed plans to be shared, allowed reputations to form, allowed stories to echo long after the fire went out. In the quiet darkness after a day of hunting and gathering, your ancestors were not just grunting at each other, they were beginning to construct entire worlds out of sound, worlds of danger and safety, loyalty and betrayal, past and future. Language had arrived not as a finished system, but as a growing, shifting tool, and with every whispered warning, every piece of gossip, every clumsy first tale, it was reshaping the human mind from the inside out. Language didn't just let your ancestors share information. It changed what information was even possible to think. Before words, your mind was already powerful. You could remember paths, recognize faces, anticipate danger. You could feel fear, jealousy, affection. You could plan simple actions like stalking an animal or finding shade before the midday heat. But those thoughts were like scattered images and impulses, loosely connected, constantly slipping away. Then, slowly, your people began attaching sounds to things, not just to objects and actions, but eventually to ideas, and as words appeared, something strange began to happen. Thought itself started to crystallize. Some linguists call this the Sapir-Whorf hypothesis, the idea that the language you speak shapes how you perceive reality. It doesn't mean language traps you. You can still experience colours your language doesn't name, still feel emotions your culture never labels. But the moment you give a pattern, a feeling, or a vague impression a word, you can hold on to it. You can examine it, combine it with other ideas, return to it later. Imagine an ancestor before words for time. They feel the difference between morning and night, between hunger now and hunger later. But once a word appears for yesterday, for tomorrow, for later, the brain gains handles on time itself. You no longer just feel the passing of days. You can talk about them, compare them, plan around them. You can ask, what did we do last dry season that helped to survive? What should we do when the next one comes? The world shifts from a continuous flowing present into something you can slice, name, and rearrange. Language didn't just describe reality, it carved it into pieces. With that carving came a new kind of thinking, abstract thinking. Long before written numbers, you could have a word like many. Soon, maybe a word like few, maybe even specific counting words, 1, 2, 3. At first, those words help with everyday tasks. How many people are going hunting? How many spears are ready? But over time, the words become tools for thinking about things that don't exist yet. If 3 people hunt, and 2 stay, and 1 is injured, what happens? You're no longer bound to what you see. You can play out futures in your head. Planning becomes deeper, more layered. You can say, if the rains fail here, we move there. If the animals change their path, we follow this river instead. You can chain conditions together. If, then, unless. maybe. Those tiny words, so small they almost disappear when you speak, are like hinges in the mind. They let ideas fold, unfold, and rearrange. They allow complex problem-solving that no other animal on Earth comes close to. At some point, language does something even more intimate. It turns inward. Today you probably hear a voice in your head when you think. Your own voice, narrating your day, arguing with itself, rehearsing conversations that may never happen. Psychologists call this inner speech. We don't know exactly when it appeared in human evolution, but once your ancestors had a rich enough spoken language, there was nothing to stop them from using it silently, privately, inside their own minds. Inner speech is like having a portable teacher, strategist and storyteller living in your skull. It lets you walk through steps before you act. First gather wood, then dry grass, then strike the stones. It helps you resist impulses. Don't shout, stay quiet, the animal is close. It allows you to talk to yourself about yourself. I am angry, but I should wait. That tiny gap between feeling and action, filled now with silent words, is one of the foundations of what we call consciousness. Some philosophers have wondered whether consciousness as we experience it, this ongoing narrative, this sense of I moving through time, actually needs language. Could a being with no words have a sense of self, or would it live as a series of disconnected moments? We can't go back and ask your ancestors before speech, but we can notice that as language becomes richer, so does the inner landscape. Once you can say I and you before and after, want and should, your mind gains the ability to reflect on itself. Not just I am in pain, but I remember being in pain, and I hope I won't be in pain tomorrow. Memory changes too. Animals remember. They can recall where food was, who is friend or foe, which path smells like danger. But human memory, once soaked in language, becomes something else. Stories. Before, a memory was a sensory echo, an image, a smell, a twinge of fear. After language, it becomes a narrative. The river dried. We walked east. We found a new spring near the tall red rock. That story can be compressed, rehearsed, polished, retold. Words act like a filing system for the past, labeling events so they can be retrieved long after the raw sensations have faded. Over generations, this transforms your ancestors' relationship with time. The group no longer depends on what each individual can personally remember. Experiences are stored in shared stories. Long ago, when the sky turned red, we went to the caves. When the sea pulled back far from the shore, the elders ran uphill. These aren't just memories. They are verbal time capsules carrying lessons across lifetimes. With language, knowledge stops dying with the body that first learned it. Think about that. Before speech, if one clever individual figured out how to make a new kind of tool or discovered a rare water source, that knowledge ended when they did, unless someone else watched and imitated them closely. With words they can explain. Take this stone. Hit it here, not there. Use this angle. In the hot season, walk until the hills split. There is water hidden between them. You no longer need to reinvent every solution in every generation. Culture starts to accumulate. Slowly, the mental world of your ancestors fills with things that no one living has personally seen. Ancestors, heroes, spirits, rules, taboos. Language lets you talk about beings who are not present, objects that don't exist yet, events that might never happen. It lets you transmit maps of places a child has never visited, instructions for rituals they will perform decades later, warnings about dangers they have never encountered. The individual mind becomes a node in a vast, invisible network of remembered words. This is where language and thought become almost impossible to separate. Did your ancestors start telling complex stories because they could think abstractly? Or did the act of telling stories train their brains to think in more abstract ways? Did words grow out of consciousness, or did consciousness grow into words? The evidence we have, the tools, the art, the burial practices, the genetic traces of our shared past, suggests a kind of feedback loop. As your ancestors' brains changed, language became possible. As language grew, it reshaped those brains, favoring individuals who could handle more words, more ideas, more subtle distinctions. That, in turn, made even more complex language useful and necessary. Thought and speech co-evolved, pulling each other upward. By the time your species was fully modern, your ancestors weren't just animals that made sounds. They were storytellers living in stories, creatures whose reality was filtered through the categories and concepts their languages provided. The night sky wasn't just points of light anymore. It was stars with names, patterns with meanings, omens, calendars, myths. The landscape wasn't just rocks and trees, but sacred places, dangerous crossings, remembered landmarks bound together in songs, and inside each skull, a quiet voice was always speaking, commenting, questioning, remembering, imagining. Language had colonized the mind, and in doing so it created the kind of mind that could wonder about its own origins, that could ask, as you are asking now, not just how we learn to speak, but what speaking did to the very fabric of who we are. Language didn't just let your ancestors share information, it rewired what it meant to be human. Before speech, your social world was small. Primates manage relationships through grooming, touch, eye contact. It works, but only up to a point. There's a limit to how many individual bonds you can maintain one-on-one. Anthropologist Robin Dunbar ran the numbers and came up with something strange. Based on primate brain size and group behavior, there seems to be an upper limit to how many meaningful relationships a brain like ours can track at once. Around 150. This, Dunbar's number, isn't a hard rule, but it's a revealing pattern. Hunter-gatherer bands, early farming villages, medieval hamlets, even modern military units and company sizes all tend to cluster around that figure. But here's the twist. Without language, your effective number would have been far smaller. Grooming one person at a time is slow. It takes hours each day just to maintain the trust and alliances you already have. Language hacked that system. Talking is like vocal grooming at scale. You can groom several minds at once. One story around the fire, one shared joke, one retold hunt, and suddenly 20 people feel closer, not just to you, but to each other. Gossip becomes a survival tool. You keep track of who's generous, who cheats, who keeps promises, who takes foolish risks. You don't have to witness everything yourself. You inherit information from the entire group's eyes and ears. This is the real revolution. With speech, your social world could expand without collapsing into chaos. You could maintain bigger, more complex networks of trust than any primate before you. Not just a band of 30, not just a loose cluster of related bands. Eventually villages, tribes, entire cultures who would never meet everyone they belonged to, but somehow still knew who we were. Once language cracked the problem of group size, it unlocked something even more powerful. Coordination. Think about cooperation before speech. You can point, gesture, maybe grunt. You can collaborate in simple ways. Chase that animal, lift this rock, follow me. But complex cooperation requires planning. It requires shared imagination. With language, you and your companions could stand on a ridge, look out over a valley and build a future in words before you ever took a step. We'll circle from the east at dawn. You wait near the ravine. If the herd turns, drive them toward the cliff. If they scatter, we meet at the river. That's not just communication. That's simulation. You're running a model of tomorrow in multiple brains at once. Over time, this ability transformed your ancestors' economy. Language made trade more than just casual swapping. Suddenly you could negotiate. I'll bring you stone from that far ridge if you share your access to the spring. You could agree to future obligations. I'll help you build your shelter now. You'll help me when my child is born. You could describe things that weren't physically present: distant water sources, hidden flint beds, seasonal animal migrations. This opened the door to specialization. If you were especially good at shaping stone, you didn't just make tools for yourself. You made them for others and got food, skins, or protection in return. If you were a gifted tracker, your skills were in demand across the band. Language let you explain techniques, teach apprentices, correct mistakes. Knowledge stopped dying with individuals and started accumulating across generations. Cooperation scaled up further when language entered the realm of alliances. Once humans could tell stories about themselves, they could invent we on a whole new level. You didn't just belong to a family or a band. You belonged to a lineage, a clan, a people. Alliances between groups became possible because they could be talked into existence and maintained through ritual, promises, and shared tales. Two bands might meet at a seasonal gathering place. In silence, it would be tense, maybe dangerous. With language, elders could negotiate. Your daughter will join our group next rainy season. Our sons will help you hunt in the dry months. Obligation becomes narrative. Memory of the agreement becomes a story you tell the youngsters. We don't harm them. They're kin by marriage. As populations grew, hierarchies became more complicated. Leaders, elders, specialists, healers, skilled hunters, charismatic storytellers. Language became the main tool for navigating this invisible landscape. A single sentence could mark respect or challenge, claim authority or undercut it. Titles, nicknames, insults, praise. These were not just words. They were instruments for arranging human beings in an invisible ladder of status. Shared language also drew invisible borders. The sounds you used, the words you chose, the stories you told, these marked you as one of us or one of them. Even subtle differences in pronunciation, favorite phrases, or mythic heroes became badges of identity. You could meet a stranger and know within a few exchange words whether they were part of your world or an outsider. This created powerful in-groups. People who shared your language felt safer, more trustworthy, more real. You laughed at the same jokes, feared the same spirits, remembered the same legendary ancestors. It also sharpened the sense of others. Those who spoke differently were mysterious, maybe dangerous. Misunderstood words could spark suspicion. Rumours about neighbouring groups could spread like brushfire through a dry savanna. Because if language made cooperation easier, it also made conflict more sophisticated. The bright side of gossip is shared information. The dark side is slander. Words let you praise, but they also let you lie. You could exaggerate a rival's mistakes, question their loyalty, imply they'd broken a promise. You could mask your own intentions, pretend to agree while secretly planning to defect. Deception existed long before humans, but language supercharged it. You could construct entire false realities in other people's minds. Manipulation became an art form. Charismatic individuals could sway groups with stirring speeches, terrifying prophecies, or comforting reassurances that might not be entirely true. Rumours could destroy reputations, fracture alliances, even justify raids or revenge killings. A story told enough times could turn a confusing skirmish into a legend of heroic victory or unforgivable betrayal. And yet, without language, your ancestors could never have built the fragile structures that stood between conflict and chaos. Across countless evenings, as fires burned low and stars shifted overhead, humans began to talk not just about what happened, but about what should happen. Stories of misbehavior and its consequences became moral lessons. Tales of generous hunters and loyal friends became models to imitate. Over time, these stories hardened into norms. In our people you don't steal meat. In our people you share water in the dry season. In our people we don't harm guests. These weren't written laws yet, but they were something just as powerful. Expectations backed by collective memory. Break a norm, and people didn't just get angry in the moment. They retold what you did again and again, until your name was associated with shame or danger. Language turned social approval into a kind of invisible currency. Reputation became as important as physical strength. Eventually, as settlements grew and disputes became more complex, these spoken rules evolved into early law. Maybe an elder would recite traditional judgments. When this problem arises, here is what we have always done. Precedent crystallized in phrases, proverbs, ritual speeches. Justice lived in words, preserved not on paper, but in the memory of the community. Culture itself, songs, myths, initiation rituals, taboos, origin stories, emerge from this steady layering of shared language over shared life. A child born into such a group didn't just inherit genes. They inherited a dense web of meanings, expectations, and stories stretching back through uncounted generations. Every word they learned plugged them deeper into that invisible structure. So when we say language was a tool, that's almost an understatement. It was more like a new dimension of reality, a second, invisible world your ancestors built on top of the physical one. In that world, relationships, obligations, identities, laws, gods, and histories could all exist as patterns of sound moving from one mind to another. Some of those patterns kept peace, some justified violence, some comforted the grieving, some divided neighbours. But all of them together did something no other animal had ever done. They turned a clever primate into a creature that could live inside shared stories. And once humans were living in stories, something new became possible. Not just surviving from day to day, but imagining whole futures, entire peoples, vast destinies, spoken into existence, one word at a time. By the time your ancestors were speaking in full, flexible sentences, they had already survived ice ages, droughts, and at least one near extinction. But there was another kind of explosion happening quietly, invisibly, every time someone opened their mouth. Languages were splitting. Not all at once, not with any dramatic crash, but slowly, like hairline fractures spreading across a sheet of glass. A family moves to a new valley. A hunting band drifts farther along the coast and doesn't come back for a few seasons. A river changes course, turning a familiar path into an uncrossable barrier. Generations pass. The people on one side of the mountain say water one way. The people on the other side say it slightly differently. A sound changes here, a word is shortened there. It is. A borrowed term from a neighbouring group slips into the vocabulary. Over a few lifetimes no one notices. Over a few hundred it becomes obvious. You still understand your cousins, but it takes effort. A few thousand years later you can't understand them at all. This is how a single ancestral language can bloom into dozens, then hundreds, then thousands. Linguists today estimate that more than 7,000 languages are still spoken on Earth. But that's just the final snapshot in a very long movie. Try to imagine every language that ever existed, not just now, but in the past 50,000, 100,000, maybe even 200,000 years. The numbers get dizzying very quickly. Some researchers think the total count might be in the tens of thousands. Others argue it could easily be in the hundreds of thousands. Every time a small group split off, every time isolation lasted long enough, a dialect had a chance to drift into something new. Tens of thousands of years give you an awful lot of chances. Why do languages diverge so easily? Part of it is simple geography. Mountains, deserts, glaciers, dense forests and oceans don't just block movement, they block words. If your band spends generations in a remote valley far from everyone else, your speech changes in its own direction. Children mishear things. New slang appears. Old words vanish. Pronunciations slide. This slow shifting is what linguists call drift. No one plans it. No one votes on it. It just happens because humans are a little sloppy and very creative with sound. Even within a single village, every generation speaks a little differently than the last. But geography and drift aren't the whole story. There's also identity. Language isn't just about describing the world. It's about deciding who we are. Tiny changes can become badges. Maybe your group starts using a particular word or a special greeting. Outsiders don't. That tiny difference grows into a marker of belonging. Over time, people might even exaggerate their speech to sound less like their neighbours. Sometimes this is conscious. You might mock another group's accent, or carefully avoid their words. Sometimes it's entirely unconscious. You simply prefer to speak like the people you trust and admire. Either way, identity pulls languages apart just as surely as mountains do. Drift, isolation, and identity working together over thousands of years turn one language into many. And if you step back far enough, you get a striking pattern. Languages cluster into families like branches on a tree. Take Indo-European, for example. It's one of the best-studied language families on Earth. English, Spanish, Russian, Hindi, Persian. They all sound wildly different to modern ears, but trace their words and grammar backwards, and you start seeing shared ancestry. Similar words for mother, for numbers, for basic tools and body parts. Tiny grammatical quirks that show up from Europe to India. Linguists use these similarities to reconstruct parts of a lost parent tongue. Proto-Indo-European. Nobody ever wrote it down. No recording exists. But by comparing its daughters and granddaughters, we can sketch out some of its sounds and words, like an echo of voices that went silent 5,000 or 6,000 years ago. And Indo-European is just one family among many. There's Afro-Asiatic, stretching from the ancient languages of Mesopotamia to the Berber tongues of North Africa. There's Bantu, a massive family that's spread across much of sub-Saharan Africa, carried by farmers and iron workers. There are Austronesian languages, somehow leaping from Taiwan across the Pacific and Indian Oceans to Madagascar, Hawaii, and Easter Island. Each family is more than just a list of related languages. It's a map of movement. Follow Indo-European and you trace the spread of pastoralists across the Eurasian steppe. Follow Bantu and you watch waves of people move through Central and Southern Africa, bringing new crops and animals. Follow Austronesian and you see daring seafarers crossing open ocean in wooden boats, carrying with them not just tools and genes, but also songs, myths, and grammar. Languages remember where genes forget. Genetic traces can blur as populations mix, but vocabulary can preserve older layers of history. For example, reconstructed Proto-Indo-European probably had words for snow, horse, and wheel, but not for ocean. That suggests an inland, temperate homeland with domesticated animals and wheeled vehicles, but no daily contact with the sea. Other families tell different stories. Some ancient language layers preserve words for tropical plants that no longer grow in the regions where those languages are now spoken. That hints at older homelands in warmer climates, long since abandoned. In a way, lexicons become fossil beds. Instead of bones in rock, you get meanings embedded in sound. And it's not just about things. Languages also whisper about beliefs. If you compare related languages, you sometimes find shared terms for gods, spirits, or ritual practices. This suggests that before those cultures split, before their speakers went their separate ways, they already shared parts of a mythological world. Proto-Indo-European speakers, for instance, might have told stories about a sky-father deity, a storm god, and a world shaped by cosmic conflict. Later cultures, Greek, Norse, Sanskritic, Slavic, reworked those myths in their own styles, but echoes remain. We can even glimpse social structures. Words for uncle and aunt can hint at whether your ancestors lived in male-dominated or female-dominated kinship systems. Terms for bride price, dowry or clan can expose marriage patterns, inheritance rules, even hints of ancient property laws. You may never recover the full story, but the outlines are still there, hidden in everyday speech. Push this method far enough, though, and you reach a strange and controversial question. If we can reconstruct Proto-Indo-European and Proto-Afro-Asiatic and Proto-Austronesian, could we go even deeper? Could all human languages everywhere come from one single original tongue, a proto-world language spoken by the first fully modern humans? Some linguists think this is at least possible. They point to recurring patterns across distant families, similar pronouns, common shapes for words like I, you, this, that. They argue that if human speech started once in one population, some deep traces might still linger, like faint fingerprints on the underside of all our grammar. Others are skeptical. Languages change too fast, they argue. Beyond maybe 10,000 years, 15,000 if we're lucky, the signal gets lost in noise, coincidences multiply. Two words might look alike not because they're related, but because there are only so many easy sounds human mouths like to make. At that timescale, firm reconstruction becomes less science and more speculation. For now, proto-world remains in that intriguing grey zone, not disproven, not confirmed, a shadow at the edge of our methods, a reminder that language is older than any script we've ever written, deeper than any record we can confidently check. And while we argue about a single original language, thousands are disappearing right now. Every few weeks, somewhere on Earth, the last fluent speaker of a language dies. Sometimes they're the final elder in a tiny community that has shifted to a national language for school and work. Sometimes they live in a village where young people still understand some words, but no child has grown up fully speaking them. When that last voice falls silent, it's not just vocabulary that vanishes. It's a particular way of carving up reality. Some languages divide colours differently. Others track direction with absolute compass points instead of left and right. Some embed social respect directly into their verbs. Others carry stories in their grammar, myths encoded in metaphors so familiar no one even notices them. Lose the language and you lose all of that. You lose specialized words for local plants and animals, honed by centuries of intimate observation. You lose jokes that only make sense in that tongue. You lose prayers, spells, curses and lullabies that once soothed children to sleep by the light of small careful fires. Multiply that loss by the thousands of languages that have already died, not just recently, but across all of human history. Think of every band of hunter-gatherers that vanished in some forgotten drought, every coastal village swallowed by rising seas at the end of the last ice age, every little tribal tongue erased by conquest, disease, or assimilation. Each one took with it a specific way of thinking, a unique answer to the question, what is the world like, and who are we in it? Today we speak global languages, connected by instant communication. But under that apparent unity lies a deep, branching forest of tongues, some thriving, some endangered, some gone so completely that not even a single word remains. And yet, whether we speak English, Quechua, Yoruba, or Ainu, we're all doing the same astonishing thing. We're turning breath into meaning, sound into shared thought. We're participating in an unbroken chain that stretches back to those first humans who, somewhere in the deep African past, began shaping their breath into symbols. From that first chorus to the thousands of languages whispered, shouted, sung and dreamed across the planet, every word you speak is part of that story. a story of division and convergence, of isolation and contact, of memory and loss. A story where even silence is full of echoes. For hundreds of thousands of years, everything humans knew lived only in one place, in living minds carried on living breath. Language was already ancient before the first mark was ever scratched on stone. Entire worlds of myth, medicine, astronomy, and lore existed only as vibrations in the air, passed from parent to child, elder to apprentice, storyteller to spellbound audience. And if a voice fell silent forever, some piece of that world usually vanished with it. That's the first strange thing about writing. It arrives incredibly late. Our ancestors were speaking in fully modern ways at least 100,000 years ago, probably longer. But the oldest true writing systems appear only about 5,000 years ago. That means for more than 95% of our species' history, humans were a talking animal with no written record at all. No books, no lists, no contracts, no diaries, just memory, ritual, and repetition. But that doesn't mean they left no trace. Long before writing, humans were already trying to pin down meaning outside the mind. They just weren't doing it with sentences yet. They were doing it with images and marks. Think of the deep caves of Europe, painted 20,000, 30,000, even 40,000 years ago. Bison, horses, mammoths, human figures, handprints. At first glance they look like art, and they are. But some researchers think they might have been something more. Repeated patterns of dots and lines next to animals, marks that cluster around certain seasons, symbols that recur from cave to cave over vast distances. Were they hunting records, calendars, spiritual shorthand for myths everyone already knew by heart? We can't be sure, but we can say this. These were not random doodles. Someone cared enough to go deep into the earth, into the dark, to make them. Someone thought meaning could be stored in pigment and stone and revisited later. That idea is the seed of writing. Outside the caves you start to see other hints of proto-writing. Not full sentences yet, but marks that stand for something countable, trackable, repeatable. Simple tally marks cut into bone or antler, sometimes in long careful sequences. Maybe they tracked days of the moon, kills on a hunt, debts owed, or offerings given. Clay tokens in the ancient Near East, small shapes representing jars of oil, flocks of sheep, baskets of grain. For thousands of years people used these tokens to keep accounts, long before anyone pressed signs into wet clay. These systems are like training wheels for writing. They don't encode language directly, but they show a new way of thinking. The idea that a mark on a surface can stand in for something that isn't there. A herd, a harvest, a promise, a passage of time. In a sense, humans were practicing for writing without knowing it. Then, very late in the story, something radical happens. In a few places on Earth, independently, people push this idea to its limit. They stop just representing things and start representing words. In southern Mesopotamia, around 5,000 years ago, Sumerian scribes begin pressing wedge-shaped signs into clay tablets. At first, these are mostly pictograms and numbers, used to manage grain rations, temple offerings, and laborers. But slowly the signs become more abstract. A picture of a head can stand for the word head, but also for the sound of the word head in the spoken language. Now you can write not just what something is, but how it sounds. You can write names, verbs, grammar, thoughts. Egypt around the same time follows a different but related path. Hieroglyphs appeared on tomb walls and ceremonial objects, little pictures of birds, eyes, thrones, reeds. At first glance they look purely symbolic, religious, decorative. Yet they too encode sounds and words, not just ideas. A name written in a cartouche can be spoken aloud correctly thousands of years later. a voice summoned across time by carved signs. In China, perhaps a millennium or two later, another writing system comes into being. Its earliest forms are scratched onto oracle bones and turtle shells, used for divination. Questions for the ancestors, for the spirits, for the future. Over generations the signs evolve, but the core idea stays. Written characters tie meaning to sound, sound to language, language to thought. That system, transformed but still recognizably related, is the ancestor of modern Chinese scripts used by over 1 billion people today. Across the ocean, in Mesoamerica, yet another line of invention emerges. The Maya develop a complex writing system of glyphs that can record history, politics, astronomy, and myth. Their monuments and codices show dates, names of kings, wars, rituals, celestial cycles. Once again, no borrowing that we can see, no connection to Sumerian wedges or Egyptian birds, just another group of humans staring at the problem of memory and deciding that speech deserved a more permanent body. These were not small changes. When speech became permanent, everything else started to change with it. Writing allowed laws to be written down instead of remembered, which meant rulers could claim they were simply following the code, even when they were really shaping it. It made contracts and property records possible, which helped create more complex economies. It stabilized religious texts, fixing certain versions of myths and prayers, turning fluid oral traditions into authoritative scriptures. Most of all, writing changed human memory. In an all-world, remembering is a survival skill and a social art. Stories are crafted to be sticky, full of rhythm, repetition, formulaic phrases. Knowledge lives in song, in epic, in proverb. People train their memories deliberately. They can recite hundreds of names, whole genealogies, legal formulas, heroic tales that last all night. Forgetting is dangerous, so societies build elaborate systems to keep knowledge alive in heads, not in objects. Once you can outsource memory to clay tablets, papyrus scrolls, bamboo slips, palm leaves, parchment, something begins to shift. You don't need everyone to remember everything anymore. You can specialize. You can have scribes and archives, libraries and schools. You can look something up instead of carrying it around in your mind. That's a gain and a loss at the same time. Writing preserves details that oral tradition tends to smooth out. You can reconstruct trade records, star catalogues, healing recipes, even personal letters from thousands of years ago. But the living, flexible, adaptive nature of oral knowledge starts to fade. Stories that once change with each telling become fixed texts. Local variants vanish. Performers become readers. Memory arts, once central to culture, become rare talents or esoteric practices. Some philosophers in ancient Greece worried about this. There's a story that Socrates told about an Egyptian god who invented writing and offered it as a gift to the king. The god claimed it would make people wiser and improve their memory. The king disagreed. Writing, he said, would create forgetfulness in people's souls because they would rely on marks outside themselves instead of remembering. They would have the appearance of wisdom, not its reality. We don't know if that story happened, but the anxiety is real. Every time we externalize our minds into a new medium, we change what the mind needs to be good at. The path from clay tablets to glowing screens is just a continuation of that process. Once we wrote in stone, then in clay, then on papyrus and parchment, paper and ink. Movable type made copying cheap. Printing presses filled the world with text. Now we tap glass and send symbols around the planet in less time than it takes to speak them aloud. Your words can appear on a device in another hemisphere faster than a shout can cross a room. But the core idea hasn't changed since those first tally marks and cave signs. We are still the same storytelling animal, still trying to trap thoughts outside the brain so they can outlive us, still worried about forgetting, still hoping that by fixing our words in some durable form, we can reach minds we will never meet. The marks look different now. The surfaces have changed. But underneath it all, it's the same ancient impulse that drove someone long ago to press the first careful line into wet clay and trust that somehow meaning could survive the silence. For all the stories we've told tonight, there's something humbling we have to admit. We still don't know exactly how language began. We have clues: fossils, DNA, stone tools, brain scans. We have computer models and clever experiments. But the first true conversation, the first sentence ever spoken, the first time a child understood a word as more than just a sound, those moments are gone forever. What we have instead are echoes, and some of the strangest echoes are hiding in plain sight. Take Basque. On the map, Basque country is small, a patch of land straddling the border between Spain and France. But linguistically it's a universe of its own. Basque is what linguists call a language isolate. It doesn't belong to any known language family. It isn't a cousin of French or Spanish or Latin. It isn't related to Celtic or Germanic or Slavic. As far as we can tell, it stands alone. When you listen to it, you're hearing something that might be a surviving fragment of a world that no longer exists, a time before Indo-European languages swept across Europe, before Latin, before Greek, before almost every tongue you can hear on the continent today. Basque may not be ancient in its current form. Languages change constantly, but its roots might stretch back to those forgotten peoples who watched glaciers retreat and forests grow where ice once stood. And Basque is not alone in its loneliness. There are other isolates scattered across the globe. Burushaski in the mountains of Pakistan, Ainu in northern Japan, Kusunda in Nepal. Languages that refuse to fit neatly into our family trees, like stubborn puzzle pieces that seem to belong to a picture we no longer have. Are these just accidents of history, or are they the last surviving stars of lost constellations, remnants of once thriving language families wiped out by conquest, migration, and time? We don't know, but they remind us that the linguistic world we see today is only the thinnest slice of what once existed. Behind every isolate is the ghost of a vanished crowd of voices. While linguists pore over these outliers, other researchers are turning to very different tools. Artificial intelligence, for example, has quietly become a new kind of time machine. You're living in a world where machines can swallow billions of words and discover patterns no human could notice in a lifetime. Algorithms track how sounds shift, how grammar drifts, how vocabulary spreads from one language to another like pollen on the wind. They can simulate how an ancient word in a proto-language might have sounded hundreds of thousands of years ago. They can test different evolutionary scenarios asking, if humans started with a simple system of sounds, what path would most likely lead to the complexity we see today? Some researchers feed old texts into neural networks to see if the computer can reconstruct missing pieces of dead languages. Others use AI to search for deep structural similarities across hundreds of modern tongues, patterns so subtle we never realized they were there. Every time the models run, they generate possibilities. Not definitive answers, but maps of what might have been. At the same time, genetics is telling its own story. Buried in your DNA are traces of ancient migrations, past bottlenecks, and forgotten encounters. Certain genes are linked to speech and language development. FOXP2 is the most famous, but far from the only one. When scientists compare these genes across humans, Neanderthals, and other animals, they find a mix of the familiar and the surprising. Some key language-related variants existed before modern humans appeared. Others seem to have spread rapidly at certain points in our past, like software upgrades installed across a population. Neuroscience adds yet another layer. Functional brain scans show networks that light up when you speak, when you listen, when you silently rehearse a sentence in your mind. But the brain doesn't treat language as a single, tidy module. It sprawls across multiple regions: memory, prediction, motor control, social cognition. When you understand a sentence, you're not just decoding grammar, you're simulating another mind, guessing intentions, predicting what might come next. This is where children come in. Every human child is a walking origin story. In just a few years, starting from almost nothing, children build a complete grammar of at least one language. No formal lessons required. They make mistakes, but not random ones. Their errors follow patterns. They say goad instead of went, mouses instead of mice. They apply rules they've never been explicitly taught, then slowly refine them. To many researchers, this suggests that human brains come preloaded with expectations about what a language can be. Not the specific words, not the exact rules, but a blueprint. A sense of how sounds can be combined, how meanings can be structured, how sentences can be built. Others argue that children don't need any special blueprint at all. They say language emerges from general learning abilities interacting with a particularly rich social environment. According to this view, children are statistical geniuses, soaking up patterns from the speech around them, slowly converging on the grammar of their community through sheer exposure. Either way, watching a child learn to talk is watching something very old replay itself in miniature. Some of the same pressures that shaped the first languages, limited memory, imperfect perception, the need for speed and clarity, are at work again in every nursery, every playground, every whispered bedtime story. We've also tried a different approach. If language is so central to being human, what happens if we try to share it with our closest relatives? For decades, scientists have attempted to teach language-like systems to apes. Chimpanzees learning sign language, bonobos pressing symbols on keyboards, gorillas pointing to picture cards. The results are both impressive and humbling. Some apes have learned hundreds of signs or symbols. They can request food, name objects, express simple desires, even string together short sequences like "you tickle me" or "gimme drink." They can improvise new combinations, suggest a glimmer of creativity. One bonobo, Kanzi, seemed to understand spoken English phrases at a level comparable to a very young human child. But there are limits. Their sentences remain short, repetitive, and concrete. Grammar is loose, often absent. There's little evidence of the open-ended recursive structure that lets humans embed ideas within ideas, nest clauses inside clauses, build stories with flashbacks and conditionals and hypotheticals. These experiments suggest that while other apes can learn symbols, the human brain may be uniquely tuned for full-blown language. The difference isn't just in vocabulary size, it's in the way we combine units into systems that can, in principle, express anything at all. This brings us to one of the most contentious quests in linguistics, the search for a universal grammar. Do all languages share a hidden skeleton? Are there deep rules baked into the human brain that constrain what a language can be? For decades, many linguists have argued yes. They point to recurring patterns. The presence of nouns and verbs, ways of marking who did what to whom, systems for asking questions and talking about things that aren't here and now. Other researchers push back. They found languages that seem to challenge almost every universal rule proposed so far. Languages without clear distinctions between nouns and verbs. Languages with astonishingly flexible word order. Languages that mark time and number in ways that don't fit our expectations at all. And yet, underneath the wild diversity, some things do seem to hold. Every known human language can talk about the past and the future. Every language can handle negation, saying that something did not happen. Every language can, in some way, talk about possibilities, about what might be, not just what is. Every language can be used to lie, to joke, to tell stories, to imagine worlds that don't exist. Maybe the true universal isn't a specific rule of grammar. Maybe it's the capacity for abstraction, for shared imagination, for using sound and gesture to coordinate minds. There are questions we may never answer. We may never know what the very first word was, or who spoke it. We may never reconstruct the full structure of the earliest languages, or decide exactly when in our evolution true syntax appeared. The first conversations left no fossils. The first myths dissolved into the air the moment they were told. But in a way that's fitting. Language was never meant to be permanent. It's a living, shifting, endlessly recycled medium. Every sentence you speak disappears as soon as it's heard, leaving only traces in memory, in behaviour, in the choices people make afterward. The origins of language are hidden for the same reason your words vanish into the night. Ephemerality is part of the design. What we do have is this: a species that can look back at its own past, ask how its most powerful tool came to be, and use that very tool to tell stories about its own beginnings. AI models, genetic data, brain scans, language isolates, and child learners are all pieces of a puzzle we may never fully solve. But maybe the point isn't to finish the puzzle. Maybe the point is the endless conversation itself, the questions that lead to more questions, the feeling, as you drift towards sleep, that somewhere in the deep past a small group of humans once sat around a fire, wondering about themselves in the very first words that ever carried wonder. Language is the quiet thread that runs through all of this. Fire, tools, migrations, bottlenecks, new species rising out of old ones. All of it depended on one strange ability. Not claws, not fangs, not speed. Just breath shaped into sound, just moving air. When you speak, you're doing something unbelievably ancient and unbelievably new at the same time. Every word you say rides on muscles and reflexes that were sculpted across hundreds of thousands of years. Your tongue and lips, your larynx, your breath control, all tuned by ancestors who survived droughts, famines, predators, and ice ages. Yet the sentence you're speaking right now has never existed before in the entire history of the universe. It's easy to forget how strange that is. Somewhere back in the bottleneck, a few hundred frightened, clever primates began to line up sounds with meanings in more systematic ways. They named places, they called out warnings, they coordinated hunts, they shared memories around the fire. Most of those sounds are gone forever, lost in the wind of deep time. But the pattern they started, the habit of mapping thought to sound and sound to thought, that pattern never broke. It's been running in an unbroken chain from their mouths to yours. Every language on earth is just a different branch of that same ancient conversation. Tonight, you are part of it. When you whisper a good night to someone you love, you're using tools that Neanderthals may have shared, mechanisms Denisovans may have refined, capacities that the bottleneck survivors paid for with fear and hunger and endurance. When you think in words, you're leaning on neural wiring that only exists because those tiny scattered groups became obsessed with sharing knowledge, with teaching their children everything they knew. And yet, for all we've learned, so much remains in shadow. We don't know exactly when the first true sentence was spoken. We don't know what the first joke was, or the first lullaby, or the first story told to calm a frightened child as the wind howled outside a cave. We don't know which ancestor first realized that a sound could stand not just for a thing, but for an idea, for yesterday, for tomorrow, for if. We can measure skulls, decode genomes, analyze stone tools. We can build beautiful models and clever theories. But the living heart of language, the way it felt to be there at the beginning, shaping the first fragile words, that part may always stay just out of reach, a mystery humming softly beneath everything we do. And maybe that's part of the beauty. Language is both map and fog. It explains and it conceals. It lets us share ideas across continents, and yet your private thoughts, your inner voice, remain yours alone. An entire universe of speech, happening silently inside a single skull. If you'd like to keep exploring these old mysteries with me, you can help keep this little corner of the conversation alive. You can like this video so it reaches more curious minds. You can subscribe if you'd like to wander further into the strange landscapes of prehistory together. And if you feel like it, you can leave a comment and tell me where in the world you're listening from. One small sentence, "I'm listening from," and suddenly, across thousands of miles, our stories touch. Because in the end, that's what language is. A bridge across distance, across time, across the deep, uncrossable gap between one mind and another. So as you drift towards sleep, let the words of this story fade into the background, like embers cooling after a long night by the fire. Somewhere, far behind you, your ancestors are still talking in the dark, still sharing memories, still passing on what they know. Their voices have become your voice. Their questions have become your questions. Let them blur and soften. Let the endless conversation continue without you for a while. Rest. Breathe. Somewhere in the quiet, the first words are still echoing, and the next words are already on their way.